Okay, this is what we call a related rates problem. One of the good things about this problem is that they actually give you the formula that relates the variables V and R. The volume of the sphere depends on its radius only, 4/3 pi r cubed. Okay, and so for a related rates problem, we're going to assume that all the variables are changing with respect to time t. For example, r is changing with respect to time, but we do not know the function that defines that relationship. So when taking the derivative with respect to t, the chain rule must be employed. So I'll refer to that as we look at this step right here. So the derivative of v with respect to t is written dv dt equals, well, we're going to employ the power rule, 3 times 4/3. Pi is just a constant. Reduce the exponent by 1. And now here's where you have to employ the chain rule. We're assuming that this r is some function of t. We don't know what it looks like, but we multiply by the derivative of r with respect to t. That's the chain rule. Okay, and this simplifies to 4 pi r squared dr dt. Now, how do we find dv dt? Well, we look back at the problem and it tells us that the radius is decreasing at a rate of 1/10 of a centimeter per minute. Another way to say that is that dr dt, the rate of change with r with respect to t, is negative 1/10 of a centimeter per minute. That's what goes here. And we want to know what is the rate of the volume of the snowball decreasing when the radius is 9. So these are the numbers that we have to plug in to this formula for dv dt. Find t, 4 pi, there's the radius, 9, times the rate of change of the radius with respect to time. That all simplifies to this. And if you want to get a decimal approximation, it's negative 101.8 cubic centimeters per minute. Now it says the answer is supposed to be positive. Well, that's because the word decreasing is included here. So we want to say it's decreasing at 101.8 cubic centimeters per minute. If you want to see why it's cubic centimeters per minute, you can actually include the units. So the radius is in centimeters, but we're squaring that. So that gives us centimeters squared. The rate of change of r with respect to t is in centimeters per minute. So if you include the units in your calculation, you get centimeters cubed per minute. Okay, there you go. Hope that helped. If you have any questions on that, post a comment.